Hi everyone, welcome to my presentation. Today I am going to focus on factors associated with duration of power outages due to hurricanes. Hurricane is a very common phenomenon in the world and also in the United States. For example, about 5 hurricanes hit the United States every 3 years. Previously, Hurricane Ida, Irma, Hurricane Michael, all of them caused a huge damage to the people. Hurricane Irma caused about $50 billion damage to the people. So when there's hurricane, there is a possibility of power outage, and if there is a power outage, people cannot work their regular works. Like they cannot cook, they cannot study, they cannot do their official works. So for because all of these works we need power, so it's very important for us to get back the power services as soon as possible, even if there is a disruption due to the hurricane. So that's why today we are going to focus on how we can find the critical regions which are more prone to longer power disruption after hurricanes, and also we will investigate to which factors are influencing the longer power outages. So basically, we have focused Hurricane Irma in this study. We have considered 58 counties of Florida. We didn't consider nine other counties because those counties there were no significant disruption in power services, and also those counties were not hit by Hurricane Irma. So from the plot, we can see for 19 counties, it took about 3 days for them to get back their power services. At the same time, we can see for some counties it took 9 days for them to get back their power services. So it's more than 7 days. It's more than a week. So it's very important to focus these issues that which are causing those regions to face a longer power disruption. And the way we calculated restoration time in this study is like when 20% or more than 20% people faced power outages, and when again there were 20% or less than 20% people yet to get back their power services. This time interval we considered as restoration time in this study. The methodology we followed in this study is like we first collected the data from different sources. Like I have already explained that we calculated the restoration time for Hurricane Irma due to the power outages, and to see which factors are related with the restoration time of power outages, we considered three types of factors like hazard characteristics, built-in characteristics of the counties, and socio-demographic characteristics of the counties. Then we looked how the restoration times are spatially distributed in the Florida state, and further we established a statistical model. So from the plot of a spatial distribution of the restoration time in Florida, we can see that southern parts of Florida were those counties faced a longer time of power disruption, and the northern part comparatively faced less. I mean, for the northern part, it took for them less time to restore their power services, and we further developed a statistical model. So when we perform a statistical model, we mainly assume that the observations are dependent. But if the data is time data or temporal data or spatial data, we need to check if if the observations are independent or not. So since this the restoration time is a spatial data, we checked if there is any spatial dependency issues. For this, we applied the Moran's I method to check if the observations are uh, independent or not, and we found that the Moran's I value is significant, and which indicates that there is a spatial dependency issues in the restoration time. So we included three types of factors like hazard characteristics, built-in characteristics, and socio-demographics of the counties. We in total included 12 variables in this statistical model, and For the statistical analysis, we performed a generalized accelerated failure time model, because this particular model considers is only for time if the dependent variable is time. So in our case, our dependent variable was time. So that's why we are performing generalized accelerated failure time model. At the same time, it considers the spatial dependence issues. So for our analysis, it's the best fitted model. And from the result of this model, we can see like four variables to be important. Like in the table, the bold ones are the independent important variables. And we found, like, among our considered variables, the wind maximum sustained wind speed, percentage of customers who faced power disruption in the counties, and also percentage of customers served by investor-owned power companies. Those three variables are positively related with the restoration time, which indicates these variables are contributing to the longer restoration time of power outages. And the number of power plants, this variable is negatively associated. So the three mentioned variables, like wind speed, a percentage of customers who faced power outage, and percentage of customers served by investor-owned power companies. So, with the increase in these variables, there is a possibility of longer restoration time for the power outages. So, in this study is mainly at county level, and we found four variables to be important. Some are positive, three of them are positively related, and one of them is negatively related. Negative association means with the increase of number of power plants, the restoration time decreased. So this is negatively related. So this is a county level analysis, but if we have the data at final geographical unit level, it will help us more to investigate which impacts are, like, on the ground, is actually causing longer disruption to the local communities. So that's all for my presentation. Thank you, everyone.